because those details matter, right? I mean, this is calculus. Those are the point. But this setup is most of the, I mean, this is like half the credit. The details after that are the other half, right? So the y integration is what? So we have...
Well, we have x squared y minus negative a.
We have to evaluate that from root x to 2 minus x, right? So this gives us the integration from 0 to 1. Let's see here. So we have x squared times 2 minus x squared root x. That's from the first term. And then the second term, I get minus x times 2 minus x quantity squared plus, now, x times the square root of x squared, right? But I can rewrite that as what?
X squared.
Right, this last term is just x squared, right? Because the square root of x squared is x again. How do I know it's not minus x?
Because you pre-distributed them.
I mean, how do...
How do you know it's not minus x? Because you're dealing with area, and presumably you want it to be positive.
Because the square is positive, or 0, yeah. So, but anyway, let's see here. I mean, I was asking, why is the square root of x squared equal to x? Is there ever a case that that's not the case?
Oh,
No. The tricky one is this, right? The square root of x squared is plus or minus x, depending on the sign, right? So there's really nothing to worry about in this case. Now, what do you got to do? Just multiply it out, right? So we got ourselves a, let's see here, 2x squared minus x cubed minus, let's see here, what's 2 plus 1/2? 5/2. Then this is minus, let's see here, I'm going to just a little in-between step right here. 2 minus x squared is what? It's 4 minus 4x plus x squared, yeah?
Yep.
So this gives me 4x minus 4x plus 4x squared minus x cubed plus x squared. So I have the integral from 0 to 1. Let me just clean this up a little bit before I actually do the integration. How many x squareds do I have in total? I got 2, 4,
7.
Yeah, 7x squared. How many x cubed do I got? There's just one of them.
2x.
Oh, there's 2 of them. Oh, thank you. I thought you said 1. I got 2 of those. I've only got 1x to the 5th, though, right? Minus x to the 5th, 5/2 rather. Anything else here?
Just your minus 4x.
Minus 4x, is that everything?
Yep. Although I'd usually cross them off as I simplify them, so I would.
You usually what?
When I'm doing a long thing like that, I always cross off the ones that are combined.
Oh, yeah, sure. Then, this integration we can do without a lot of thinking, right? So this gives me 7/3 minus 2/4 plus, let's see here, 5/2 plus 1 is 7/2, so that's 2/7. And minus 4/2, yeah, which is 2, thank you. So then, whatever that is, yeah. Now, I mean, you should simplify that, right?
You did all of the
Oh,
things.
yeah, fine. So that's
I'm laughing because I totally did it.
I know, but I feel guilty. Let's see here, 2/7 minus 2, yeah. Let's see, what's the least common multiple here? 42. What's that? 5/42? Okay, obviously. Thank you. Yeah. Put me out of my misery. I appreciate that. Thank you. Okay, question. If you have this snow cone, right, and you wanted to calculate the integral of z dv over the snow cone, and let me be more specific. What's the snow cone we're looking at? Let's say that this phi naught is what? Let's make it pi over 6 for the sake of discussion. Right.
Question: is this a slice out of a? Well, a slice isn't quite the right. Okay.
So
it's
suppose
one
we have
area, which is nice.
we have a sphere of radius r, which is intersected by a cone radius, angle pi over 6, right? And if you look at this, rho less than or equal to r, and phi less than phi between 0 and pi over 6, this defines a volume, which I call a snow cone, And so it's meaningful to ask what's the integral of z over this volume. So how should you do this problem? In Cartesians? No. In cylindrical coordinates? Tempting. It's got a cylindrical function, right? But nah. So I think definitely spherical is the way to go here. And so what we got is integral from 0 to 2 pi, right? We've got integral from 0 to pi over 6. And the integral from 0 to r for rho. Z is what? Z is rho cosine phi. And then my volume is rho squared sine phi d rho d phi d theta. Yeah, it's multiplicative, right? So we have basically integral from 0 to 2 pi of d theta. We've got the integral from 0 to pi over 6 of sine phi cosine phi d phi, and the integral from 0 to r of rho cubed d rho. So that's what? That's 2 pi. This is 1/2 the cosine of 2 phi. See, because that's 1/2 sine. That's 1/2 of the sine of 2 phi, and then, I need a minus, don't I? And then over here, we've got r to the 4th over 4 from that integral. Let's see here. What is the cosine? If you plug in pi over 6 here, we get what? Cosine of 2 pi over 6, which is cosine of pi over 3.
Are you sure that shouldn't be 1/4? Because the trigonometric identity is 2 times right? And then you do another, and then you have the 2 phi inside of the.
Okay, so you're saying that's. I think you're right. I forgot my u substitution. Is your point?
Either 1/2.
Yeah, that's a 4th.
One.
I think it's a 4th because this. Okay, so we have sine phi cosine phi is this over 2.
Yeah.
And sorry, I know we're almost at the end of class, so I was skipping a detail here, but integrate that gets a minus 1/4 cosine 2 phi. Now, what's the cosine of 2 times pi over 6? Cosine pi over 3, which is 1/2, yeah. So this is 2 pi times minus 1/8 plus 1/4 times r to the 4th over 4. And let's see here, that's what? So we've got 2 pi over 8 times r to the 4th over 4. Yeah. So I would encourage you on the next test, right? If I ask a question like this, don't just dismiss it as if it's like an impossible problem. It's not. Integration over a snow cone isn't a bad thing at all. It's actually a pretty nice problem.
Yeah.
And
Although when you first drew that, I thought it was going to be a right circular cone topped with a hemisphere.
Ah,
So that's a little less.
it's the same thing, just pi over 4. But I mean, we could do other things. We could cut out a plane at the bottom, right?
How did you just know immediately that any right? That doesn't make sense.
X
A
plus y
right
plus
circular
z.
cone with a hemisphere on top, you'd have to split into two parts.
If we had x plus y plus z equal to 1 like that, then you could, this would give you, you'd convert to rho cosine. So basically your inner radius wouldn't be 0 anymore. It would be some yuck as given by this. I mean, this you would convert to. Anyway, we're done for today, so let me not make it worse. So what was, I don't understand what you're talking about, Thomas.
A right circular cone with some arbitrary inner.
Oh, you mean, so like,
Arbitrary radius. Or
yeah. So you're saying, oh, top that off with a.
that. And so the radius of the hemisphere on top is equal to the radius of the base of the cone. But then you have an arbitrary colatitude there. So you've got two parts.
Thanks for class, Josh.
Yeah. I don't think that changes anything unless I'm not seeing it, because if I go from the origin, the first thing I hit is that.
But how do you calculate rho?
How do you calculate the bound?
Why, isn't that given? Oh, you're saying that's not given?
You have, okay, so.
I mean, the problem doesn't make sense unless you say what this is.
Okay, so you have.
Because
the cone.
because I can draw. See, Thomas, I can draw this, right?
Mm-hmm.
And there's this, and then there's this, and then there's